Alright, so the first few rules are chain rule problems. So in problem number 1, I'm going to bring down the 5 using the power rule. Make that to the 4th power times the derivative of the inside, which is 15x squared minus 7. And because I would have to distribute, I'm just going to leave the answer like this. That's it for problem number 1. For problem number 2, we have y equals sine 3x to the 5th quantity squared. So when I take the derivative, we got 2 sine 3x to the 5th to the 1st times the derivative of the inside, which is times the cosine of 3x to the 5th times the derivative of the inside, which is 15x to the 4th. The 2 and the 15 can get multiplied together pretty easily, so I'm going to make this 30x to the 4th sine 3x to the 5th cosine 3x to the 5th. In problem number 3, I'm going to have to use the product rule. So the first part is 3x to the 3rd, so the derivative is 9x squared. We got sine of 5x to the 4th, the derivative of that is cosine 5x to the 4th times 20x cubed. Multiply the insides and the outsides. So y equals, let's see, we'll make that 60x to the 6th cosine of 5x to the 4th plus multiply these two together, and we get 9x squared sine 5x to the 4th. Can't add those together, so we are finished. When taking the derivative of this one, we are going to use the quotient rule. Alright, let's try that again. 3x plus 5 cubed, and the derivative is 3 times 3x plus 5 to the 2nd times the derivative of the inside, which is 3, so I got 9 times 3x plus 5 squared. G is equal to x squared, so g prime is equal to 2x. So the derivative is, when I multiply these two together, I get 9x squared 3x plus 5 to the 2nd. When I multiply these two together, I get 2x 3x plus 5 to the 3rd divided by x squared squared, which is really x to the 4th. Now they all have an x in common, so I got 9x times 3x plus 5 squared plus 2 3x plus 5 to the 3rd over x to the 3rd. Alright, so we got this problem. We're trying to find the derivative, so I'm going to do 6x minus 10y, y prime equals 0. So I'm going to subtract 6x to the other side. Negative 10y, y prime equals negative 6x divided by negative 10y. So y prime equals 3x over 5y. For these problems, I have to do the product rule on the first two terms. So that's going to be 6x y squared plus 6x squared y prime. For the second term, I'm going to do it again where I get 5y plus 5x y prime. The derivative of negative 2x is negative 2 is equal to 0. I'm going to move anything that doesn't have a y prime to the other side. So I'm going to subtract, and add to the other side. So due to my limited space, I'm going to move the 6x squared y prime over plus 5x y prime equals negative 6xy squared minus 5y plus 2. I am now going to factor the y prime out of the left side by using an eraser because we had y prime in common, because that's what happened. So y prime is now equal to negative 6xy squared minus 5y plus 2 divided by everything that was in parentheses, which is 6xy squared plus 5x. And of course, none of you are going to cancel anything out because that would break the rules of algebra. Alright, for this next one, I'm going to do the cosine of 3x plus 2y times the derivative of the inside, which is 3 plus 2y prime equals 1. So I'm going to divide both sides by the cosine of 3x plus 2y. So I got 3 plus 2y prime equals, well, the reciprocal of cosine is secant. And so now I'm going to solve the rest of this for y prime. So I'm going to subtract 3. So 2y prime is equal to secant of 3x plus 2y minus 3. And then I'm going to divide both sides by 2. And that will give me that answer. Give you a nice little easy one here at the end. I probably meant to give you a second derivative problem right here. When I take the derivative, I get this. Subtract 2x on both sides. Negative 2y equals negative y prime equals negative 2x. Divided by negative 2y. The negatives cancel, the 2's cancel, and we're left with x over y. Alright, in our related rate problems, we are taking derivatives with respect to t here. So y prime equals 6x dx dt. And actually I shouldn't make this y prime, I should make it dy dt. Minus 4 dx dt. And of course the derivative of 2 is 0, so I don't have to worry about any dx dt's. So I got 6 times 2 times 3 minus 4 times 3. 36 minus 12 means dy dt is equal to 24. Alright, for this next one, when I do dy dt, I get 4 times 3x plus 2 to the third times the derivative of the inside, which is 3 dx dt. Since x is equal to negative 1, and dx dt is equal to 2, let's see, this is going to be negative 1, so I got 4 times negative 1 times 6, which equals negative 24. Alright, I have a radius of the circle is growing at 3 centimeters per second, and it's asking about area. So the derivative of area with respect to time is 2 times pi times r times dr dt. They told me that r was equal to 5 and dr dt is equal to 3. And so we have 30 pi, and we are at centimeters squared per second. Finally, we have a 15-foot ladder. This is 4 feet. I don't know the height, but I know that the ladder is being pushed closer to the building, and we want to know how fast this is going up. So the first thing I'm going to do is I'm going to figure out where we're at now. So 4 squared plus b squared equals 15 squared. So we got 16 plus b squared equals 225. Subtract the 16. B squared is equal to 209. Square root. So b turned out to be about 14.5 right now. So in this, I'm going to call this A. I'll call this B. I'll call this C. So a squared plus b squared is equal to c squared. So when I take the derivative, I get 2a dA dt plus 2b dB dt is equal to 2c dC dt. Now in this problem, since the hypotenuse is a 15-foot ladder, this is 0. So we got 2 times a, which is 4, times dA dt, which is negative 0.5, because a is getting smaller, that's why dA dt is negative, plus 2 times 14.5 dB dt equals 0. So this turns out to be negative 4 plus 29 dB dt equals 0. Add the 4, 29 dB dt, divide both sides by 29, and since we already rounded once, we may as well round it again. So 4 over 29 is the same thing as 0.138 feet per minute. And that is all for our review.